All right, so for 3.6, this section is called complex zeros. And our task for today is going to be writing polynomial functions. And you are going to be given complex zeros, and you are going to be given real zeros. Okay, you have made polynomials before with only real zeros. And now we're going to have complex and some irrational zeros as well. So I asked you guys to read through this theorem that says if you have a polynomial with real coefficients and if the complex number is a zero of that polynomial, then the complex conjugate is also a zero. So they're calling the complex number z. You don't have to have like that variable memorized, but just remember if it's a complex number, it's in the form a plus bi, and then its complex conjugate, which is the symbol is z with the line over it, that is going to be a minus bi. That is also a zero. So this does relate to what we were doing yesterday where we were multiplying by conjugates to simplify the denominator. So if 2i is a zero, what I wanted you to fill in is that negative 2i would be a zero. And if 1 minus 3i is a zero, then 1 plus 3i is a zero. Okay, now all of these complex zeros are going to come in pairs, okay, because there's 2i, then it's negative 2i. Okay, let's think about why that is. Okay, where do the imaginaries come from? They come from where? Yeah, the square root of negative 1, right? So anytime you're taking a square root, what do we have to make sure we put in front of that square root? Plus or minus. So complex numbers occur when there's a negative under the radical. And we are going to, we're only going to work with square roots for this. It is going to happen with any even root. And this means, so we'll just continue, which means our solution contains a plus and a minus, or a positive and a negative. Okay, so complex numbers, you don't have to write this down, right? This is where they come from. When you're taking the square root, anytime you do that, you'll have a plus or minus. Okay, that's why it's going to come in a pair. Okay, so it says what other zeros come in pairs? So we just took the square root of a negative to get this, but it doesn't have to be a square root of a negative. It can be any square root. Okay, and again, it can be any even root. So let's write down that what other zeros can come in pair when you have a square root in the zero. Okay, and then for our examples, I'll give you a zero, you give me its complex conjugate. Well, I guess this one will just be your conjugate. Okay, so root 3, you tell me what its buddy would be. Negative 1 minus root 5, you tell me what its buddy would be. Okay, so if you have root 3, negative root 3 would also have to be a zero. Remember, it's a plus bi and a minus bi. So the a, negative 1, has to stay, and then it becomes plus root 5. All right, so we're going to find a polynomial with integer coefficients that satisfies the given conditions. So the first polynomial we are going to make is q. It has a degree of 3. So remember, if it has a degree of 3, that means it has how many zeros? 3 zeros. Okay, so if it's a degree 3, there has to be 3 zeros. But they only gave you -2 and I. What other value has to be a 0 based on the theorem that we just talked about? Yeah, -I. So that's going to be your third one. All right, so sometimes they'll give you all the zeros. Sometimes you might have to find the other one. Okay, so 3 zeros because that is always going to equal the degree. Okay, so 3 zeros, it's equal to whatever your degree is. All right, now we're going to set this up in factored form. Remember, whenever you're writing out your factors, okay, your factored form is x minus whatever your 0 is. Okay, so it's going to be q of x equals, and then I feel like you can do this part without me. Let's give it a try. So you're going to have 3 factors. And then if you would like to, you think you can FOIL them, you can do that. Okay, so for -2, you should have x plus 2. For I, you should have x minus I. And then for -I, minus a negative is going to be plus. So x minus I, x plus I. Okay, and then your third step is going to be to multiply these out. So when you multiply, if they are binomials, you're going to use FOIL. Sometimes you might have to distribute. And then to make things as simple as possible, when you are FOILing, okay, FOIL the conjugates together first. Okay, so make sure you FOIL the conjugates together. So we're going to FOIL x minus I times x plus I. Okay, so x times x is x squared. You don't have to write out the inside. We've been working with conjugates for a couple of days now. So when you multiply, you have negative ix and positive ix. Those are going to cancel. You do have minus I squared. And when you plug in your -1 here, minus a negative is going to turn into a +1. And then you still have this x plus 2 in front. So we're going to multiply those together, which again just happens to be a FOIL type of multiplication. So x times x squared is x cubed. You do want to put this in standard form. 2 times x squared is 2x squared. 1 times x, 2 times 1. This is going to be your polynomial. Okay, all of the coefficients are integers there. All right, what questions do you guys have for me on that one? All right, let's try part B. So part B has 3 zeros because the degree is 3. Okay, and then they give you 1, 15 minus 6i, and 15 plus 6i. If they give you 3 zeros, then you don't have to find any others. Okay, just be careful. As we continue on this, you're going to want to add more zeros, but with one like 1, you don't have to have -1. That doesn't have to happen. It's only if you have a root or if you have an I. Okay, so we're going to write x minus 1 as our first factor. Okay, and then because these are binomials, we didn't have any binomials in the first one, but here you have binomials. If you have a binomial, those get brackets. Okay, and then I'm just going to go over this part slowly at first. And then if you are catching on pretty quickly and you want to work ahead, that is fine. So you have x, and then the form is always x minus, right? X minus your 0. Because it's a binomial, we want to put it in parentheses. So it's x minus 15 minus 6i, and then x minus 15 plus 6i. Okay, so we're keeping that factor form the same. You're subtracting the 0. Because you have a binomial, we are going to distribute the negative. So this is going to be x minus 15 minus a negative becomes plus. Okay, and then why don't you go ahead and distribute the second one? Okay, and then is there anything you notice about these terms here? You have x minus 15 plus 6i, x minus 15 minus 6i. What's something we recognize? Do we have the same values in part of them? You have x minus 15 and x minus 15 in both of them. What we're going to do is we're going to regroup this so that we can FOIL. Okay, do you have to do that? No, you could distribute everything here. You could distribute x to everything and then negative 15 and negative 6i. Okay, it would take longer, but you could do it. Okay, but I do recommend that you do the regroup and FOIL. Okay, and when you are FOILing, what you're going to do is multiply the first term by the first term. Because we regroup these, our first term is now x minus 15 and x minus 15. Okay, so when you multiply those together, it's x minus 15 squared. That's the first times the first. So x minus 15 times x minus 15 is the first of. The inside and the outside, because they're conjugates, what's going to happen? If they're conjugates, the inside and the outside should do what? Should cancel. So then let's do the last times the last. So what's 6i times negative 6i? Negative 36i squared. Okay, and then we can continue to expand here. So x minus 15 squared, remember you don't distribute, you FOIL. Okay, this is a perfect square trinomial. X times x is x squared, negative 15x and negative 15x is negative 30x. Okay, and then 15 times 15 is 225. When you plug in the negative 1, you get plus 36. And then let's combine our like terms. Okay, so if you add 6, you get 231. If you add 30, 261. And then we still have this x minus 1 in front. Okay, we are going to distribute. I'm going to line mine up so that I can add them together. Okay, but if you want to make one big line and then combine your like terms, you can. Okay, I'm going to give you a moment to do that now. Okay, and then once you multiply everything by x, you get x cubed minus 30x squared plus 261x. When you multiply everything by -1, all of the signs just become the opposite. Numbers are the same, but you just have your opposites here. I like to set it up like this so I can add straight down. Okay, and you can use that strategy too if you would like. Oopsie. Okay, so your final answer is going to be p of x equals x cubed minus 31x squared plus 291x minus 261. And this one's p of x just because they tell you that it's called p. Okay, and then once you've done that, go ahead and let's start part C, which is a degree of 4. All right, so they give you 2 zeros. You are going to have to write the other 2. So -1 plus 2i, and then -√6. When you are writing out this first step, this is Rx, keep the conjugates together. That's what you're going to want to multiply. So you have x minus, and then the 0 goes in the parentheses. X minus, the 0 goes in the parentheses. Okay, and that's if it's a binomial. So you have -1 minus 2i, and you have -1 plus 2i. Okay, that's how you start. For the √6's, you don't have to have brackets because it's one term. So you can do x minus √6 and x plus √6. Okay, and as long as you multiply the conjugates together, it doesn't matter what order you go in. It might be easier for you to start with these. X times x is going to be x squared. The inside and the outside are going to cancel. What's √6 times √6? 6. So this is just going to be -6. Okay, so whatever we get from these two multiplied together, we're going to have to multiply by x squared minus 6. Okay, so the first thing we're going to do is distribute. Minus a negative is going to be plus. So it's +1 and plus 2i. Okay, and then if you've done this correctly, when you regroup, your x plus 1 should be the same in both of them. All right, so I'm going to give you some time now to try that out. Once you finish part C, if you want to go on to part D, you can do that. I'll let you know when to check in with me. Okay, and then let's check to make sure this part went okay. So when you do the x plus 1 squared, if you guys want to like just start writing that out, that is fine. You could do x squared plus 2x plus 1, and you could put this next to it and then make that plus 4. Okay, but I do need to see like this part, the negative 4i squared with this. And then we already did the x squared minus 6. We are still multiplying these two together. So when you are distributing, you can decide if you want to do x squared to these, and then 2x and then 5, or I decided to do my x squared and then my negative 6. So if I multiply everything by x squared, I get x to the 4th plus 2x cubed plus 5x squared. If I multiply by negative 6, I'm going to make sure that I line up my like terms here, and then I can add down. And this one is called r of x, so r of x equals x to the 4th plus 2x cubed minus x squared minus 12x minus 30. Okay, so if you were working ahead, will you take one moment and just double check your answer for part C is correct? Okay, and then as you are working on part D, this one you have 0 as a 0. So the degree is 5. You're given 3 zeros, which means you have to come up with the other 2 based on your rules. So 5 plus 2 root 2 means 5 minus 2 root 2 is also a 0. 4 minus I means 4 plus I is a 0. And then if you are writing this as a factor, just keep in mind your form. Your form is always x minus c. So if you have x minus 0, you can leave it like that, or if you want, what is x minus 0? X. I usually throw that in front and make that the last thing I do. You can choose if you want it at the front or at the back there. Either way, I like to do that at the end so you can distribute the x last. And then both of these are binomials. So when we start here, we should have x minus 5 minus 2 root 2 and x minus 5 plus 2 root 2. Okay, and then I'm going to give you time to set up the rest in case you haven't had time to do that yet. If you are working ahead, I put the answer for part D on the board so that you can check your answer. And then the bookwork problems are also on the board. So if you've done part B and it's correct, you can go on to the mandatory bookwork. Yep. Okay, so as you practice these, you are going to notice some patterns start to emerge. Okay, you're going to get better, faster, stronger. Okay, so you have x minus 5 plus 2 root 2, x minus 5 minus 2 root 2. Okay, so now we can regroup. I like to just work with one of these at a time. So when you're doing this, if you do x minus 5 squared, what I'm saying is if you want, you can write just x squared minus 10x plus 25, that's fine. And then it's minus 2 times 2 is 4, root 2 times root 2 is 2, negative 4 times 2 is negative 8. Okay, and then your x is still in front. So you have x squared minus 10x plus 17. Okay, and then we're going to look at the values of I. Oops, before I do that, I'm going to distribute. So minus 4 plus I and minus 4 minus I. Okay, again, you are welcome to write out this step as x minus 4 squared. Okay, you have to assess yourself, okay? If you're somebody that's very visual and it takes us a little more time to process, this might be more useful to you, just to make sure you aren't forgetting any of your signs. And then a negative times a negative is going to be plus. So what you're going to end up multiplying together is x times x squared minus 10x plus 17. And then x squared minus 8x plus 17. So some people distributed the x first and then distributed the trinomial. That's fine. I like to distribute the trinomial first. It does not matter. Your final answer will be the same. So if I distribute x squared to everything, I get x to the 4th minus 8x cubed plus 17x squared. Okay, then I'm going to distribute the negative 10. So that gives me negative 10x cubed. Negative times a negative is a positive. Negative times a negative. Negative times a positive is a negative. Okay, and then the last one, I got 17x squared minus, and this I wrote out. So I said, okay, 10 times 8 is going to be 80 and 56. So 136x, and then 17 times 17 is 289. So now I'm ready to add straight down. So x to the 4th minus 18x cubed plus 7 and 7 is 4. And then that would make 11. Those are both negative, so 6, 10, 306. And then I just like multiplying everything by x at the end. And this guy is called t of x. When I multiply everything by x, the exponents go up by 1. Okay, if you haven't taken a moment to check that already, please do so. Okay, and then you have 6 problems that you are completing today. Okay, so it's page 276 for 3.6. So 4 of your questions are from the book, 36, 37, 38, and 40. And then it says 2 questions that are given in class. So I'm going to give you zeros. Okay, and we've been working so well. So I did have 4, but I cut it back to 2, okay? Because it was going to be, 8 problems. Okay, so the zeros are negative 2i and 1 plus root 2. And I'm going to give you the degree as well. And then 2 is 2 plus I, root 3, and 1. For number 1, the degree is 4. For 2, the degree is 5. And you can call both of these p of x.